Now let us start with the new chapter, Motion in a Straight Line. This chapter you have studied in class 9th and almost 30% of the chapter is theoretical, and today I will only explain these things. No need to write these notes in your notebooks, only this is the brushing up of your mind. Now what is mechanics? Mechanics is the branch of science, branch of physics which deals with the objects whether they are at rest or in motion, It consists of three parts: the statics, kinematics and dynamic. What do you mean by the static? Static is the branch when you are studying the objects when they are at rest, and kinematics when you are studying the objects when the objects are moving and you are not knowing the cause of the motion. And for dynamic, this is the branch when you are studying when the objects are in motion but you are knowing the cause, why they are moving, what is the cause of their motion, why they are stopped, what is the cause of their stopping nature, and these kind of studies comes under the dynamics. Now the question is rest and motion. What is rest and what is motion? You have already studied. When any object is not changing its position with respect to the surrounding, then that object is at rest. And when the object is changing its position with respect to the surrounding, then it is known as motion. Now question is there, the rest and motion are relative to each other. How they are relative to each other? You know, students, for explaining the rest or motion condition of any object, we have to explain first the frame of reference. What is the frame of reference? It is the frame, it is the point with respect to which we compare the position of the object. Suppose you are sitting in a bus and bus is moving, the passengers are sitting besides you. What is happening there? The bus is moving with respect to the trees, road and other vehicle, and you are also moving because you are sitting inside a moving bus. You are comparing yourself with respect to the trees, vehicles and the road. But when you are comparing yourself with respect to the passenger who is sitting with you, he is at rest and you are at rest, it means you are not changing your position. In that situation, you are at rest, and with respect to the outside trees, you are in motion. Hence you can say the rest and motion are relative to each other. Any object is never at 100% rest or never at 100% in motion. So the frame of reference is playing the important role in explaining the position of the object. And next is, can a body exist in a state of absolute rest or of absolute motion? It means that a body is at 100% at rest or not. I have told you earlier, a body which seems at rest in one frame of reference, in another frame of reference it may be in motion. Hence we can say any object is not at 100% rest and not at 100% motion. So absolute rest and motion are not possible. Next is the point object. What is the point object? Point object means when a very small object, and this small object is traveling a very large distance, in that situation you say that this object is the point object. What is the definition? If the position of an object changes by distance much greater than its own size in a reasonable direction of time, in a reasonable duration of time, then the object may be regarded as the point object. For example, Earth can be regarded as a point object for studying its motion around the Sun because it is completing its one round in 365 days. It means the Earth is considered to be a very small object as compared to its journey. A train under a journey of several hundred kilometers can be regarded as a point object. It is traveling a very large distance as compared to its size. And the next one is the motion in 1, 2 and 3 dimension. How you can explain it? Motion in 1 dimension, you are moving in a straight line. You may move along the x-axis, you may move along y-axis, and the motion may be along z-axis. But when you are considering only one axis, whether it is x or y or z, only one axis is in consideration, that type of motion is known as one-dimensional motion, the rectilinear motion, or you can say the translatory motion. These type of motion are in the category of one-dimensional motion. For example, motion of a train along a straight track, motion of a freely falling body. This is along x-axis and this is along y-axis. And what do you mean by two-dimensional motion? This is the coordinate system. This is x coordinate, this is y coordinate, and if you draw the z coordinate, then this is z coordinate. In this situation, when you are considering any two axes for explaining the position or motion or change in the position of the object, whether you are having the xy plane or you are having the yz plane or the zx plane, when you are considering two plane for the change of position of the object, in that situation you say the object is moving in two dimensions. And what are the example? Motion of a planet around the sun is the example of two-dimensional motion, and a car moving along a zigzag path on a level road is also considered as the two-dimensional motion. Next one is three-dimensional motion. What is three-dimensional motion? I have told you the coordinate axis. When you are studying any event, suppose an object is kept here and you are measuring its distance from x-axis, from y-axis, and as well as from the z-axis. When you are considering all the three axes in that situation, you say that the object is in three-dimensional motion. And for the three-dimensional motion, three coordinate axes are to be studied. Suppose initially the object is here and you will write it as P, the three coordinate axis x1, y1, z1, and its journey is ending at point P2. You will write it as x2, y2 and z2. This kind of motion is also known as the motion in the space. When we are talking about the two-dimensional motion, that is also known as the motion in a plane. It is motion in a space. And examples are a kite flying on a windy day. It moves up and down, left, right, forward, backward, and you can have the three coordinate axes there. So that is under the category of three-dimensional motion. Then the motion of an aeroplane in space, that is also considered as the three-dimensional motion. Now the next concept is distance and displacement. You will read it from the book. I will send you the notes. Only the reading for these 2-3 pages is suggested to you. No need to write these notes in your notebook. I will tell from where we have to write. This is only the basic introduction of the chapter motion in a straight line.